Okay, now we're going to talk about linear approximation. So one method, the method I'm going to use, it looks like this. Linear approximation is equal to f of x plus the derivative of the function times the delta x. Okay, so another way to look at it, and this is how some professors will teach it, let's look at the point slope formula, the traditional. Okay, so slope x minus x1, that's the delta x. Slope is in calculus it's instantaneous velocity. So if we add the y to both sides, look at what the y1, y is equal to y1. Oh, look at that's f of x plus slope times x plus x1. Well, that's the delta x. That's the slope. So essentially, this is the point slope formula with just adding the y to both sides. So you can think of it that way. And some professors will actually use that and not use this linear approximation. I was taught using this, so I'm going to use that method. But what you first have to figure out is what is the x, that's called the x naught, and the delta x. So what you're looking for, remember, delta x, these numbers are going to be very, very small, and smaller in reality than what we're using here. But for this one, well, the closest perfect square to 24.8 is 25. So x naught is 25. Well, that means, so if this is the original, this is x naught, and 24.8 is here, then we have to subtract 2/10. And 2/10, subtracting 2/10 is the same thing as subtracting 1/5. All right, so we have that set up. We know our, and then the f of x is just square root function. And so f prime of x is 1 over 2 times the square root of x. And you could do that manually. Remember, x to the 1/2, bring the 1/2 in front, and then 1/2 minus 1 is negative 1/2. So 1 over 2 and x to the negative 1/2 means you'd bring that down here like that. All right, just to refresh the brain on that derivative and how I got that. Okay, so we have what we need, and now we can plug it into this formula. So the linear approximation is f of x, which is square root of x, plus the derivative, which is 1 over 2 times the square root of x, times delta x. Or dx, we could put dx. All right, so now we can plug all those values in. Well, I don't know what I just said. Square root of 25 plus 1 over 2 times the square root of 25 times negative 1/5. So let's see. Square root of 25 is 5. Down here, the square root of 25 is 5. 5 times 2 is 10. So this is 1/10 times negative 1/5. So we have 5 plus negative 1 over 50. So I would multiply top and bottom by 50. 50 times 5 is 250. Subtract 1, and all of that is over 50. So what we have is 249 over 50. And then the approximation is you're going to go ahead and divide that. I should have had my calculator handy. 249 divide 50, 4.98. So let's do another one. I'm going to move this. Okay, for 8.01 to the fourth, well, that function is just x to the fourth. So the derivative of that function is 4x cubed. The x, the closest integer, is 8. The delta x is 100th. All right, so linear approximation is f of x, which is x to the fourth plus the derivative, 3x cubed, times delta x. Oops, except for that's 4x cubed. Knew that looked weird. All right, and then you plug in the numbers. So it's 8 to the fourth plus 4 times 8 cubed times 100th. 8 to the fourth is 4,096. And then plus 4 times 8 cubed is 12. Now, I'm going to take a moment and I'm going to look at this. 4 goes into 100 25 times. I'm going to cancel that out, and I'm going to put a 25 right there. That will simplify stuff a little bit. So now what we have is 4,096 plus 512 over 25. So I'm going to have to multiply this top and bottom by 25. So let me 25 times 4,096. That's what I have. Looks like 102. I don't know that I'm liking this. Plus 512. All of this is going to be over 25. Which is 102,912 by 25. Well, if you take 8.01, you 8.01 to the fourth power, it's 4116.518. So that's pretty close, just in the linear approximation, using the linear approximation. I was getting a little bit nervous about these numbers, so yep, it worked out okay.